All right, in 7.7, so far we've worked with common logarithms. That's the ones with base of 10. Again, anytime you see a regular log button, that's a log base 10. We've also evaluated logarithms using our calculator. There's another type of logarithm that is called a natural logarithm, and it is a logarithm with base e. Just as log base 10 of x translates to be a common log, we should make sure we learn that log base e of x is what we call ln of x. Again, ln is natural log. I don't know why it's ln. You could Google that and probably find out. But the variable e itself is called a natural number. Its value should be memorized. In general, is about 2.178. But you can use your calculator to remind you when necessary, typically. Let me see. Yeah, there we go. This calculator has an ln button. The ln button leads to e, as most of them will. I think even the other ones do as well. ln has an e above it. Again, just going through all my toys here. Natural log, is it here? Yeah, there it is. Natural log ln has an e to the x. And again, if you want to know the value of e, all you have to do is e, which means second ln, and then put the power of 1, because again, anything to the power of 1 is itself, and notice that it converts to be 2.718, blah, blah, blah. So again, if you ever forget the value of e, just type it in as a power of 1 and your calculator will tell you that. But we're not so much here to learn about e as we are to learn how to solve equations containing natural logs and the variable e. And there are two fundamental rules that we have to learn when working with these problems. Number one, you eliminate a natural log by using e. Number two, eliminate e by using a natural log. So this is a very simple connection between these two things. You just have to make sure you learn how to work with them together. So I'm just going to go ahead and get right to the examples and point out whenever we're using these two rules here to our advantage. So example 1, scientists have found that alligator's length L in inches and weight, this should be a parentheses, and weight W in pounds are related in the following equations. So they give us an equation relating length and width, and they want us to estimate the length of an alligator that weighs 341 pounds. Now here's where you have to pay attention on this question, because it asks for two things. First off, they give us the weight. That means that 341 goes in for W, which means we are looking at L equals 26.2 ln of 341 minus 59.3. Sorry for my crazy ghost decimal right there. But anyway, with that, we just type it in. Again, this is nothing to really solve. So 26.2 ln of 341, just like with everything else, make sure you close your logarithm before you do your plus 59.3. It says that it should be 93 feet long. That is a very long alligator. But anyway, no, that's inches. Okay, I was about to say, I'm like 93 feet. I know I messed that up. But anyway, and I say that because I make these problems up and I don't consider what the answer actually means. But 93 inches actually makes more sense than 93 feet. That's a big alligator. That's more like Jaws. But anyway, notice all you had to do is just type it in. So 26.2 ln 341 minus 59.3 gave me my answer. And to the nearest, or to one decimal place, it would be 93.5 as your answer. So that's the easy one. That's the one you don't have to worry about solving, because all we're doing right there is just substituting and going straight through. Now it says estimate the weight of an alligator that is 55 inches long. So this is where they actually give us the length, and so we have to take this formula and put 55 for L and fill out the rest. So 26.2 ln of W minus 59.3. So this is where we get into solving here. Our goal is to get to W. W is directly attached to a natural log. The natural log is being multiplied by 26.2 and then subtracting 59.3. So the first thing we're going to do is move our 59.3 by adding it, which is 114.3. Why is my screen scratched right on the decimal point? But 114.3 equals 26.2 ln of W. And so now what we do is we get rid of the 26.2, of course, by dividing. So 114.3 divided by 26.2, which is, oh man, we're going to one decimal place. So if you're going to round, I would round with that same thing. So I'll do 4.4. Again, every time we approximate, we cut off more and more, but I think it should be fine like that. Anyway, with that said, again, dividing by 26.2 gave us this. Now we need to get rid of the ln. And here's where we use our rule. Eliminate a natural log using e. Eliminate e by using a natural log. This is a natural log. So what we do with a natural log is we take the base of e and make both of these things a power. And what happens is e to the 4.4 stays, but e and ln cancel out, bringing down just w. So when you go to find your answer, again, e's and natural logs cancel out. And so what happens is you just type in your e using second ln or whatever button you would use to the 4.4, and you'd get 81.5 would be your weight. So consider the other one. 341 pounds was 93 inches or so. 81 pounds is about 50 inches. I think it makes sense as long as you don't get an answer that isn't way out of whack with, you know, the way the problem's set up. But the bottom line here is in, I can't draw a star right now, is in these two steps. So again, once you get down to your natural log, to get rid of that natural log and get w by itself, use e as a base and translate both of these parts to be a power. The e and the ln cancel out, bringing down just whatever is attached to the natural log, and then you go ahead and evaluate whatever's going on. So that is your first part of how to deal with that. Just make sure you've, again, got that highlighted so you know where the new information is. The rest of the information, I think, is pretty standard, but again, getting rid of a natural log is something you've never done. Population of a country is modeled by the function blah, where p of t is the population, t is the number of years since 1800. They want to know when the population will be 200 million. So again, you have to read carefully. This is not time. This is when will the population be 200 million, which again, p of t is a population, so you're going to put the 200 because again, it's in millions. So put the 200 there for p of t equals 60 e to the 0.04 t. And so we're going to look for time. So in this case, again, the t is up here in the exponent, which is attached to an e. The 60 is here. I think we'll get rid of the 60 first. And they want time, so I'll just be safe and go 2 digits just to be safe. So 3.33 equals e to the 0.04 t. So again, looking at this, t is up here. The only number I have to get rid of an e now. I can't get rid of the 0.4 until I got rid of the e. So now we go back to our rule of eliminate an e by using a natural log. So what we do is, this is, since e usually takes things up to a base, the natural log just moves on. So it'll be natural log of 3.33 equals natural log of e to the 0.04 t. And again, what happens is natural log and e both cancel, bringing down natural log of 3.33 equals 0.04 t, because again, those two things go away. And the last thing we're going to do is divide by 0.04, and so I'm going to do that pretty much in fraction form because that usually works for me. So natural log 3.33 over 0.04 gives me, again, about 30 years, so 30 equals t. But again, it's when. It doesn't say when in terms of time. It's saying when in terms of 1800. So of course it would be 1830 would be your answer there. Because remember that t is a number of years since 1800, so you have to kind of factor that back into your answer. So again, make sure you understand your crucial part here is from here to here. When you had the e to the power, so you did the natural log on both sides, the natural logs cancel out, this came down, and pretty much, again, you could have rounded that, but I don't know if it's really worth it if you're going to be doing the calculator work anyway. Now, the second question is very important for you to understand. How long does it take for the population to double? Well, double from what would be your first question, and that is where you have to remember your general format for a formula, which is y equals a b to the x is usually the case, and we know that this usually represents the starting point. And so looking at that, it means that our population right now is 60 million. Based off of this formula, we know it's 60 million because it's initial value and then something with some other things in time, but that's always been the initial value. So what we're looking for is when it will be 120 million. And so that's what you need to pay attention to. Whenever you're asking for the population to double, you will have to do some research using what you know to kind of look and say, what is the population to start? And again, the population starts at 60. If you want it to double, we want it to be 120. And so therefore, that's what we're going to do. When we divide by 60, it'll be 2 equals e to the 0.04t. Which from there, again, to get rid of e, this is a crucial part of your learning. Natural log of 2 equals natural log of e to the 0.04t. Again, natural log and e both cancel. So natural log of 2 equals 0.04t. And again, if I divide by 0.04, I'm just going to steal this up here. Oops, if I can do it right. So natural log of 2 over 0.04 is what I end up with, and I get about 17. So 17 years for the population to double from where it's at would be your answer. Again, if they want a decimal, 17.3. If you want to miss the question just to see whether they round it, go ahead and do that. Because remember, again, your overall idea is to adjust to whatever. I guess I'm kind of going against myself. Your overall idea is to make sure you don't waste your time. And to not waste my time, I would probably miss this question on purpose just to make sure if I need to round it or whatever it might be. But that's up to you. However you work through your problems, just make sure, again, you've got good notes and that you ask where you get stuck. C. Solve. Natural log of 15x minus 43 equals natural log of 7x plus 21. This is where all our lists of strategies come from. And in this problem, I remember it that the natural log of something equals a natural log of something, meaning that in this case, the natural log really isn't even that important. Because really what has to happen is that 15x plus 43 just has to equal 7x plus 21. So as long as you remember that strategy, you're much better as a mathematician as a result. That ends up being 8x minus 43 equals 21. Adding 43 ends up being 8x equals 64, which is nice because that means that x would equal 8 in that problem. But again, the key thing to remember is the natural log problems are just the same as the log problems. Same strategies. Use your head, use your common sense to make sure you know where you're going. And then the last one I'm going to do, which doesn't represent everything you'll see, but you've seen everything that you're going to have to deal with so far in your homework. Honestly, you've seen it before we even do this, but just to do it for the sake of giving you something else to practice. Again, I'm getting to x. X is a power of e. It's been multiplied by 2 and added to 9, which means 9 would be the first thing I get rid of. So 2e to the x is greater than 44. Yeah. Then divide by 2. E to the x is greater than 22. And then from there, again, we need to get rid of an e. And the way we get rid of an e is with a natural log. And by the way, I do the cursive L so I don't confuse it for one N. But other than that, like I said, that means these two go away. X is greater than whatever natural log of 22 is. And they want 4 decimal places, so 3.0910. And as I said, in a science class, you'll do that, but I don't know if Math XL really has it go to the 0. If you miss it, or I'd put the 0, and if it says you're wrong, just take the 0 away, because again, the computer doesn't always do what we call trailing zeros, and this is a trailing 0 because outside of wanting 4 digits, it's not even important to that answer. So other than that, like I said, this covers the main parts of your work today. There are different types of problems, but again, as long as you remember how to eliminate LN, and E, you should be fine. So let me know where and when I can assist you, and again, make sure you're ready to show me your work so I can help you fix your decisions. But other than that, have a good day and good luck.